I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. Today, we are going to discuss about continuous probability distribution. Before going to the topic, what all main things we are going to discuss about it, we can have a look over there. Random variables, definition of continuous probability distribution, and regarding continuous probability distribution, we are going to solve few problems also. Definition of random variables. What is the connectivity of this random variable to the topic continuous probability distribution? First, that we will discuss about it. Here we can see a small circle. In the outside, the capital S is written. The capital S, it's nothing but sample space. What is sample space? So now, if I have a coin, a single coin, if I toss that coin, what are the outcomes are going to come? We know it, head will come, otherwise tail will come. If my idea is I'm expecting that I want to get head, the same head, what I'm expecting, if I get, then I got success. If I'm not getting, failure. So, if one coin, if I toss, we know the possibilities head or tail. Those possibilities, those outcomes are denoted by sample point. They will be written here. Now, these outcomes are converted into real numbers. The capital R denotes real numbers. That is, who is converting these outcomes into real numbers? So we need some help. That job, that work is being done by random variables. You can see it here. So the X is it is denoted by capital letters only, random variables. This capital X is satisfying some identical conditions which will be imposed on the sample space, satisfying the conditions. What are the outcomes which will be converted into real numbers? This capital X is called otherwise random variable, otherwise real valued function. We can see the definition now. A random variable capital X, that's what I told already. The capital X, it's denoted by capital letters. And we can call it as stochastic variable or variate also we can tell. So it is the conditions on the sample space, we can call it as X from S to R. X from S to R, that only here it is there. So this X is, otherwise it is called it as, we can call as real valued function. That assigns a real number X of S. Suppose the one coin I told, H and tail. This is a possibility, we know it. So X of S, head, suppose my expectation is, I want head. So if I get head, I am success. But that should be denoted in a real number. 1 we can take it. If I am not getting head, then failure. So 0. So 1 head, it is connected to 1. No head, it is connected to 0. This is the fundamental, the work which is done by random variables. So you can see it. To each sample points, S belongs to S. They are the outcomes. It's nothing but sample points. All the sample points are there in sample space. Sample space is denoted by capital S. Thus, Capital X of S represents the real number which the random variable capital X associates with the outcomes. That's what we have seen it. Capital X, which is converting this head into a real number. If our question is number of head is our expectation, then head is connected to 1. But unfortunately, we are not getting head, we are getting tail. Then failure. We are not getting head. Our expectation is head, but we are not getting head. So no head. That mathematically it is connected to 0. The set of all possible values taken by a random variable, capital X, is called the image X. So we can tell this X, this is in the function domain, this is range. Otherwise, this is image, this is pre-image. It is a subset of your real number R. Random variables are denoted by the capital letters capital X, capital Y, capital Z. Mostly we are taking the random variable, this lecture, capital X. Now what is this connectivity? This random variable to the topic continuous probability distribution. That we have to see now. So now we are taking one small example, that is, find the range of 2 coins are tossed to get number of heads. This is only our expectation. And what are the coins? How many coins we have? 2 coins we have. 2 coins we are tossing. 1 coin tossing, giving some gap in the sense some minutes. After minutes, another 1 coin. No, that is not, we are not doing that one. At a time, 2 coins we are tossing. And our expectation is number of heads we want it. So we can see it now. So let 2 coins be tossed simultaneously. This is very, very important. At a time. Yes, denote the sample space of the experiment. Yeah, this is one experiment. We are tossing the 2 coins. In the experiment, what we are expecting, we want the number of heads is our experiment. If we get the number of heads, we are success. We got success. That capital S, it's nothing but total possibilities of these 2 coins tossing. What are the total possibilities? Head, head. That is first coin head, second coin head. First coin head, second coin tail. First coin tail, second coin head. And both the coins tail. These are the total possibility if 2 coins are tossed. We know the formula also, especially for the coin. 2 power n is the formula. How many coins? 2 coins. So 2 square equal to 4. So 4. This is also one of the way we can check whether what are the total outcomes. 4 total outcomes we got it. That means 4 sample points we got it. Because we know it, each sample point, it's nothing but 1 outcome. We got it. And we checked against, that is towards the formula 2 power n 4. Yes, we are moving. We are proceeding the problem in a correct path. Now we can see it. Capital S, it's nothing but our sample space. HH, TH, HD, TT. These are all written inside the sample space. The meaning is the 2 coins are tossed. The total outcomes are in the sample space, which is denoted by capital S. Now, HH, then we are naming as S1. TH, we are naming as S2. HT, S3. TT, S4 we are giving. Now, capital R, Now, what are the possibilities? The real numbers, you can see it 0, 1, 2. Capital X is nothing but random variable. Our question is number of heads. First, you can see it here. H it is there. How many heads are there? 2. So first here we have taken, there is no head. Our condition is number of heads, but in this particular sample point, there is no head. No head. Mathematically it is 0. That is a real number. Next, TH. In this, how many head is there? 1 head is there. That's what it is connected to. 1, the real number. HT. Here also 1 head is there. It is connected to 1 real number. Next, HH. How many heads are there? 2 heads are there. They are connected to the real number 2. Clear? Now, so the random variable, the sample points, or the outcomes of the sample space, they are satisfying the function condition. It is coming out as real number. So it is capital X is a random variable. It is nothing but real valued function. Now, this continuous probability distribution is our topic, but we are talking about random variables. What is the need? What is the necessary of talking about random variables? Because the random variable, it has 2 types. The first one is discrete random variable. Next one is continuous random variable. The continuous random variable distribution is continuous probability distribution. That one of the type of random variable, that is continuous random variable over the probability distribution, that we are going to discuss. So it's nothing but here you can see it, the range of X. So the first we already studied in lower classes. This is domain, this is range 0, 1, 2. According to our question we have the problem 2 coins. That's what strictly 0, 1, 2 it is there. Suppose instead of 2 coins, if it is 3 coins, then the sample points also will be increasing. So according to this problem, the real numbers 0, 1 and 2, the range is 0, 1, 0, 1, 2. Yeah, we will move to now continuous probability distribution. What is that? We can discuss. When a random variable capital X, so we got it now, the clear picture about what is random variable, what type of work it is doing mathematically, that is also we understood. Now, this random variable, it has 2 types in the continuous probability distribution. How? That means it takes every value in an interval it is taking. It gives rise to continuous distribution of capital X. The distribution is defined. Now, your child is there at the age of 5. If you are seeing the height is some. But after 10 years, if you are noticing the same child, the height will be increasing. Gradually the age is increasing, the height also increasing. So if you want to measure from the particular child from age 5 to 10, what is the height increased? How much the height is increased? So continuous from one particular point to another point. So such type of thing we will use continuous probability distribution, where the random variable capital X is playing the role in an interval. Yeah, we can see it. Now, the probability density function, otherwise we can call it as continuous probability distribution. We can see here f of x is greater than or equal to 0 for all x belongs to real number. That means the probability which is equal to 0, I am using the word equal because of this symbol. Greater than 0, mathematically it is. The meaning is it is positive. So greater than or equal to 0, that is the probability is 0 or positive. And f of x, the integration from minus infinity to infinity, the value which is equal to 1. These two conditions are satisfied, then it is probability density function or continuous probability distribution. These two formulas, these 2 points, we have to keep in our memory space very strongly. Now, one more part it is there, continuous probability distribution, cumulative distribution function of a continuous random variable. We can call it as cumulative distribution function, or we can tell simply the distribution function of a continuous random variable, capital X, which is denoted by capital F of X, and is defined as capital F of X, which is equal to probability of X less than or equal to X equal to integral minus infinity to X F of X. Now, thus capital F of X gives a probability that the value of the variable capital X will be less than or equal to X. We have to keep it in our mind. This is the formula for cumulative distribution function. Mean of the continuous probability distribution. What is the formula? It's nothing but mu. It's nothing but mean. E of x. It's nothing but expectation of x, which is equal to integral minus infinity to infinity x f of x dx. Now, variance of a continuous probability distribution. Sigma square equal to integral minus infinity to infinity x minus mu the whole square f of x dx. Otherwise, integral minus infinity to infinity x square f of x dx minus mu square. So very, very important formulas in the continuous probability distribution is mean, variance, and cumulative. These are the very, very important formulas playing a role in the continuous probability distribution. Now, we will solve one problem. If the probability density of a random variable is given by f of x equal to k of 1 minus x square, for that x lies between, that is x lies between 0 and 1. From 0 to 0 is not included because here that equal sign is not there. So 0 to 1, the function is this one. Remaining other intervals, whatever it is, then the function is 0. That is the meaning of this question. Then what they are asking us to find? Find the value of k, and the probabilities that a random variable having this probability density function will take on a value. The questions, 2 questions, we are asked to do it between 0.1 and 0.2, the first question. Second question is greater than 0.5. So now the function is given. The function, when x lies between 0 to 1 only, this function is exist, not other intervals. Strictly it is told in the problem, and they are asking us to find what is the value of k. That is the first target. As a question it is put on us here. Next, between 0.1 and 0.2, what is the value? Greater than 0.5, what is the value? So this we have to solve it now. Yeah, it's a very simple thing. I'll tell to all the students. You find the value of k, the constant it is there. 100% you can go the total probability distribution. We know it is total probability is always equal to 1. That formula if you take, easily we can come out with the answer. We can see it. What is given? First we are writing. So it is given, the function is given. Just we copied from the question and we wrote it. Since the total probability is unity, is 1. We know it. Always the total probability is 1. Now, this is the density function to prove. Because the question itself, the starting only it is given. If the probability density of a random variable, it is given. So that is the reason we have taken this formula. Now, here the thing it is there, minus infinity to infinity f of x dx equal to 1. Formula it has the integration from minus infinity to infinity. But our function x lies between 0 to 1. Strictly if it is 0 to 1 only, we can substitute this function. But here f of x, it is not possible to substitute this function because the reason is it is the integration from minus infinity to infinity. Then what to do? How to proceed the problem? Yes, this 0 minus infinity to infinity. We know it. Here 0 is there. Minus infinity, this is infinity goes on. 0 to 1 also here only in middle it is there. So we can insert the 0 to 1. Here we can insert it. We can insert this 0 to 1 in middle of minus infinity to infinity. So that is the reason we can see it. Minus infinity to 0, our formula integral, which we are expanding, we are splitting into 3 parts. Then only it is possible to substitute our given function. Minus infinity to 0, 0 to 1 and 1 to infinity. We actually now we splitted the integral. Always mathematics, what we are doing, it is correct or not. When a fraction of second, we have to check and we have to proceed. Then there is no room for committing errors. No mistakes at all. How to check? You can see it easily. Here 0, 0. That only we inserted. 1 we inserted. You can see 1 is up, 1 is lower. 1 is up, 1 is lower. Left over minus infinity to infinity. That is only our formula. So we inserted in a correct way, which gives an indication. Yes, you can proceed further. Yes, yeah, we can do it now. Now one more thing. What is this? We split it to satisfy our given problem condition. The x lies between strictly 0 to 1. That is the reason 0 to 1 we inserted. Everything is fine. How to read this one? X from minus infinity to 0. The meaning is what? X minus infinity to 0. But in the question we can see only this function. That means this comes under otherwise condition. Otherwise condition, the function is 0. So the first integral place 0. That means first integral is vanished. What about the middle, the second integral? X, how we will do it? How we will read it? X lies between 0 and 1. Yeah, exactly. It satisfies our given problem condition. So this f of x, we are going to substitute this function, that is k of 1 minus x square, because that integration from 0 to 1 only satisfying our problem condition. Fine. So the middle, the second integral exists. What about the third one? Third one, how we will read? X from 1 to infinity. That is 1 to infinity. But 1 to infinity also otherwise condition only. Otherwise condition, what about our function? 0. So only the middle integral exists. Even the third integral also vanished. 3 integrals, first and third, they are vanished. So we are going to neglect them. Only middle one we are going to consider. So this is the question it is written. Yeah. This is the last step of the previous slide. It is kept here. Yeah. Now we understood very clearly about this. Why the first integral, the value is 0? Because the reason is x lies between minus infinity to 0. It falls in the condition of otherwise the function is 0. So it is getting vanished. Next, x lies between 0 to 1. Yes, it completely satisfies our given problem condition. That is the reason f of x is replaced by k of 1 minus x square. Plus the third integral also getting vanished. The reason is the third integral, x lies between 1 to infinity, falls on otherwise condition. Yeah. So now, only the middle integral exists. We can do the comparison of the steps. While actually the students, while actually seeing this video also, this is the next step, before step. What are the changes are there? You can see it. Now the changes, here the before step k, after the integral it is there. The next step, the k has become before we brought it. Each and every step, we have to do the comparison with the previous steps. Now this is fine. Now we have to do the integration. Very simple integration only we are going to do. It's not very complicated. Integrations are not going to play in the role of this continuous probability distribution. Very simple integrations. Yeah, fine. Now we can see it, x power n dx. The integral is the x, it has the power n. So x power n plus 1 divided by n plus 1. X power n plus 1 divided by n plus 1. We will compare with our problem. X square is there. So n is playing the role 2. N is playing the role 2. So now x square, it's nothing but x 2 plus 1 by 2 plus 1. Dx integral, it's nothing but x. This please keep it in our mind. Dx integral is x, and x it has some power, then we can use this formula. We will go to the next step. Yeah, k is written as it is 1 into this dx. Yeah, we know it. Integral of dx is x, and this x it has written as it is x square. Just now we did x square, it's nothing but x cube by 3. It is written 0 to 1. 0 to 1, which is equal to 1. Here it is there. Now k simplifications we are doing. We know actually how to apply the limits. Upper one is 1. In the place of x, we will substitute. The reason is we did integration with respect to x. With respect to x we did. That is the reason in the place of x we are substituting the value. So x is taking here 1. This minus is minus. X cube, it's nothing but 1 cube. 1 cube is 1. So 1 by 3. This is formula minus. It's not related to our given problem minus. What is the difference between given problem minus and formula minus? Yeah, it is there. While doing mathematics, we have to be very careful about the signs. It's from my side, it's a very humble request. We have to, now here 1 minus x square is there. This minus is the given problem sign. Whereas this minus is, it is not related to our given problem. It is the definition of the limit. Wherever the limit comes, upper minus lower. Here this minus is related to the formula. So very while solving the problem, this sign related to our given problem, this sign related to our formula, from the formula it has come. This picture is very clear to all the students. There is no error in mathematics, there is no mistake at all. We can see it now. Yeah, k is written as it is. Clear? So 1 minus 1 by 3, it's nothing but 2 by 3, which is equal to 1. So 2k by 3 equal to 1, k equal to 3 by 2. So first question we solved, that is k equal to 3 by 2 with the help of total probability distribution is 1. Then using this function strictly, x lies between 0 to 1. Keeping in our mind, we proceeded the problem and we found k equal to 3 by 2. So totally 3 questions are there. 1 we found. The next question is, the probability that the variate will take the value between 0.1 and 0.2. See our question, 0 to 1. In the between 0 to 1 only, this value is also included. Yeah, fine. So we are splitting because we know the formula, integral minus infinity to infinity f of x dx. This is only our formula, minus infinity to infinity. We inserted 0.1 to 0.2. After inserting, we can check it whether we inserted it is correct or not. You can see it here. Yeah, correctly we inserted. The left should come minus infinity to infinity. First one is vanished because x lies between minus infinity to 0.1. It doesn't satisfy our given problem condition. Second one, it satisfies. X lies between 0.1 and 0.2. It satisfies because 0.1, 0.2, they are between 0 to 1 only. Here only, between that only 0.1, 0.2 exist. So, f of x is replaced by the function. Third one doesn't exist because x lies between 0.2 and infinity. It falls on otherwise condition, that is also the value is 0. Only the middle integral exists. Okay. Now this is actually integral, we have to do it. We can see it here. K we have to bring it front, but instead of k, it is written, we can notice it easily, it is written 3 by 2. The reason is just now we found the value of k, that is 3 by 2. In the place of k, we substituted the value 3 by 2. Then 0.1 to 0.2, 1 minus x square dx. It is written from the previous steps as it is. This 3 by 2 as it is 3 by 2. Dx, the integral is x, minus is same minus x square. In the integral, we have to substitute. So, x square dx, the integral we know it. N is playing the role 2. So, x cube by 3. That is only written here. So, 0.1 to 0.2. This 3 by 2 as it is, upper limit 0.2. In the place of x, we have to put it 0.2. So, 0.2 minus 0.2 the whole cube divided by 3. This minus is formula minus upper limit minus lower limit. So, the lower one is 0.1. So, x place we will put it 0.1 minus, then x place we can put it 0.1 the whole cube divided by 3. So, 3 by 2. You can use the calculator, otherwise manually also we can do the simplifications. 0.2 minus here 0.2 the whole cube. It's nothing but 0.008. This minus has been taken inside. Minus into 0.1, minus 0.1, minus into minus, plus. So, we did the actual simplifications. So, simplifying we are getting 3 by 2. Here it has been taken LCM. The final answer we got it 0.1465. So, second question also we solved it. That is between 0.1 and 0.2, what is the probability? The third question is the probability that the variate will take the greater than 0.5. So, x is greater than 0.5. It is written, it's such a long sentence mathematically. This is the meaning, probability of x greater than 0.5. So, straight you can put off 0.5 to infinity. That is, the starting is what? 0.5 to up to, it's not given. It is understood that it is up to infinity. F of x dx. Now, the big question is, now this f of x, it is replaced by this function. That is a question to us. Is it possible? This f of x place, we can substitute this k of 1 minus x square. It is not possible because x lies between 0 to 1 only strictly. But here x lies between 0.5 to infinity, it is there. It is not possible. Then how to do it? We can split it. 0.5 to 1 plus 1 to infinity. You can see it? Yeah. The balance should come before our step. Then we are moving in a correct way. Now, x lies between 0.5 to 1. Now, this f of x, we can replace it. Yeah, we will come here. X, question is 0 to 1. Now, here 0.5 to 1. 0.5, here only it is there. To 1, yeah, we can substitute. So, the first integral exists, whereas second integral doesn't exist. Because the reason is, x lies now 1 to infinity. It comes under otherwise condition. Very simple problem. We must understand the given problem conditions. That's it. Now, the first integral exists. So, 0.5 to 1 k of 1 minus x square dx. This is the simple, that is the integral formula. We are going to use it. Now, it is written as it is. K we put it. This dx, it's nothing but we did the integration x. X square, we are now very familiar. X cube by 3, 0.5 to 1. This is the limit we have to apply it. Now, k is written. Now, if you want actually here, the k value, what we got it out of, straight away also we can substitute it. Here, nothing wrong in it. Otherwise, the last step also we can substitute. Any way we can do it. That's what we are understanding the problem, the concept of the problem. If you understand very clearly, the simplifications we can do on our own way. It's not strictly what a particular person is following. The same simplifications we can mathematically, any way we can do it. Okay, here this upper one is what? 1. In the place of x we are substituting 1 minus 1 by 3. Clear? This is formula minus. Upper minus lower. Lower is what? 0.5. In the place of x we are substituting. So 0.5 minus 0.5 the whole cube. That is 0.125 divided by 3. So the last step it is kept. So here k value is 3 by 2. If you want, that's what I told. The initial stage only the k value, if you want to substitute, we can substitute. Nothing wrong in it. The first one, simplifying, we got it. 2 by 3 minus is kept as it is. This simplification is 1.375 by 3. So the final answer we are getting. So all simplifications, LCM doing, we are getting 0.3125. So very simple actually. We have taken one problem and we did determine this k value. Next 0.1 to 0.2, what is the probability? And greater than 0.5, what is the probability? Then we solved completely one problem. We finished it. We will move to the second one. Now, is the function defined by? One function is given that it is a density function or not? That is the question it is. For that, what all they are asking? X is less than 2. Strictly they are telling the function is 0. If x lies between 2 and 4, the function is 1 by 18 of 2x plus 3. Whatever other intervals, that is otherwise, the function is 0. And the given this f of x, you test whether it is density function or not. And find the probability that the interval falls, x lies between 2 to 3, what is the probability? So that is also, it is asked us to do it. So we will see it now. For all the points, we know it, the formula, continuous interval, x lies between minus infinity to infinity, and the probability always greater than or equal to 0. So we are taking x lies between minus infinity to infinity, f of x dx, which is equal to 1. Integral minus infinity to infinity, f of x dx equal to 1. This is the total probability distribution, which is always 1. If it is, we proved it, it is a density function. Because density function or continuous probability distribution, the starting only we discussed it. It should satisfy two conditions. In the two conditions, this is one of the condition. So this one of the condition, to prove it, we have taken this formula, left side we have taken. So solving this integration, we are getting the value, the right side 1, then it is a probability density function. Yeah, we will see it. Yeah, this is the given actually, the question. Integral minus infinity to infinity f of x dx. So, but we can see it. X is less than 2, one condition. X is, lies between 2 and 4, one more. Then the function is this one. Remaining whatever other interval, then the function is 0. So this is given to us. According to satisfy our given these conditions, we have to make our formula, we have to expand it in such a way to satisfy our problem condition. So we will do it. So minus infinity to 2, 2 to 4, minus infinity to 2, this one. X is less than 2. So less than 2, 1. So 2 is there. Whatever the less than, 1, 0, minus 1. It goes on up to minus infinity. That is the meaning of this x is less than 2. Then, so it satisfies x lies between minus infinity to 2. So, according to that, it is written x 2 to 4. Yeah, we did. The third one is otherwise. We know it. Whatever we are inserting, we will check ourselves. We inserted it is correct or not. So, we can see it. 2 correct. So, 4 is up. Compulsory down. It should come. The balance should satisfy the previous step of the formula, minus infinity to infinity. So, according to that problem conditions, we splitted the integrals. Now, the first integral, f of x dx. X lies between minus infinity to 2. Clearly, it is given the function is 0. So, the first integral is vanished. What about the second integral? X lies between 2 and 4. F of x is replaced by this function. That is 1 by 18 of 2x plus 3. Strictly it is told. It is not I am telling. It is given in the problem. X lies between 2 and 4. So, f of x is replaced by this function. Next, x lies between 4 and infinity. That is otherwise. So, the third integral vanished. Only the middle integral exists. So, the first one you can see it is 0. This is also 0. Now, so minus 1 by 18 we are bringing out. Next, we are doing the integral part. This 2 is kept as it is. X integral. So, x integral, x power is 1. X power is 1. We have to do the integral. So, formula we know it. X power n plus 1 by n plus 1. So, our n is 1. It's nothing but 1 plus 1 to x square by 2. That only it is written here. This plus is as it is. 3 dx integral we know it. X. The 2 getting cancelled. Balance it is written here. 2 to 4. Upper limit is 4. Lower one is 2. So 1 by 18 of x place we are substituting the upper value is 4. So 16 plus 12. Upper is 16 plus 12. Here formula minus. Here 4 plus 6. It is 10. Simplifying we got it 1. Yeah, we proved it. That is integral minus infinity to infinity f of x dx equal to 1. This is one of the condition that we will call that the distribution as continuous probability distribution. Then the particular function is density function. Yeah, we proved it now. The value which is equal to 1. So the given function is probability density function. Yeah, one more question it is there. So this is our question thing. X lies between 2 and 3. So 2 and 3, f of x dx. And the function 2 and 3. Which one is straight also we are substituted here. 2 and 3, you can see this is the condition. Between 2 and 4 only 3 also it is there. So this function exists for this particular question. Because 3 is between 2 and 4. There is a reason the function exists. We substituted replacing f of x by 1 by 18 of 2x plus 3. The integral formula is kept. So 1 by 18 just we brought it out. The 2 is written as it is. X integral is nothing but using this formula. The x power is 1. So x square by 2. This is the integral. 3 is written as it is. Dx integral is x. 2 to 3. So 1 by 18. This 2 getting cancelled. The balance it is written here. 2, 2, 3. Now, 1 by 18 of upper one is 3 minus, this is formula minus, upper minus lower. So, upper value is 3. In the place of x, we have to substitute because we are doing the integration with respect to x. That is the reason the place of x, we have to substitute the values. So, 3 square is 9. 3 into 3, 9. Next, the lower one is 2. In the place of x, we will substitute 2 square, 4, and it is 6. So, 1 by 18 of 18 minus 10. So, we got the value 4 by 9. So, this particular problem, 2 questions they put on us, we solved it. The first one is, the function is given. They asked us to test whether it is density function or not. We tested. We got the value 1. Then we told the given, we know the formula, that is integral minus infinity to infinity f of x dx, which is equal to 1. Then we will call it as probability density function. The second question is, x lies between 2 and 3. That is also we solved it. X lies between 2 and 3, which satisfies the problem condition. 3 intervals are given. The middle one it satisfies. According to that, we substituted, we integrated, we got the value 4 by 9. Yeah, today's lecture, what all we did, we will come to one conclusion. Yeah, first, sample space and real number, random variable. This outcomes, whatever is there, or sample points, with this help of random variable, they are converting into real numbers. That we discussed it. That is the random variable, about it we discussed in detail. Next, continuous probability distribution, that we discussed it. Mainly we focused on these 2 conditions are satisfied, then it is continuous probability distribution. And this function is probability density function. And we have taken, then we moved to problems to solve using this continuous probability distribution, how we have to face it. Yeah, this problem we have taken. In this k value we found, taking the total probability distribution is 1. Using this formula, we found the value of k. Next, 0.1 and 0.2. This, it should be inserted in between this. That how it played a role. In detail we discussed it. And greater than 0.5, how to tackle, we tackled it. Next one problem we have taken, f of x equal to, the 3 parts are there, x is less than 2, x lies between 2 and 4, otherwise. Here they asked us to test whether it is this given function is a density function or not. We know it. This is the one of the condition for continuous probability distribution exist. So, this integral we substituted, we got the value 1. And we did x lies between 2 and 3. We found the value of that particular probability because it satisfied this condition. So, everything we in detail we discussed it about continuous probability distribution. Thank you very much to all.
Like, share and subscribe. Hit the bell icon for more updates.